Hello guys, welcome to Hardcoder. In this video, we are going to see the Leetcode problem number 835 image overlap. Let's get into the question. Leetcode 835 image overlap. The problem statement is you are given two images, that is image 1 and image 2, which is represented as binary square matrices of size n into n. So a binary matrix will have only values zeros and ones. So we translate one image, however we choose by sliding all the 1 bits left, up, right and down for any number of units. So we can translate the given image. We can translate one image. So the translation is nothing but moving the 1 bits to any of the 4 direction. Every 1 bit should be moved to any of the one direction. For not only one direction, but it can have any number of any combination of directions for any number of units. And we, after doing the translation, we will place the image on the other original image, that is the image one image. If we choose to translate the image 1 and we are placing it in image 2, we need to find the number of position in which both the ones overlap. So after this, we need to return the largest possible overlap. This is what mentioned in the question. So the time taken for me to understand and complete this approach is 1 hour, and I took 1 hour to complete the solution. So let's get into the approach. So yeah, this is the test case which is given in the question. So before moving on to question, we will see the problem statement. So the problem statement is define the problem. We need to define the problem before moving on to approach. So problem is nothing but two arrays, that is int image 1 and image 2. Both arrays are given. So output should be max overlap after translation. This should be the output. So the input is image. So we can have translation is nothing but moving all 1 bits to directions left, right, up or down. So this is the problem statement, and let's see how to approach this problem. So how can we approach this problem? We will just try to we'll just try to translate to every possible way. Translate a image to, let's take a image to, we can also choose image 1 to translate to, we'll translate the image to all possible ways. This is the first step, and second step will be to find the number of overlapping ones. This is what our approach is going to be. So how are we going to build the solution? So it's nothing but firstly we'll move on to every direction. So we are going to find the translate all the possible ways. How can we translate? We are going to translate in all the direction, that is left up, right up, left down and right down. So we are going to move the image 1 to all the 4 direction. So firstly we'll have the image 2, and firstly we'll move to the left up direction. So in order to do that, we'll take the image 1 and start with original image 1, image 2. So we'll place the image 2 on the image 1 and check the number of overlapping ones. So let's call this step as check. First step will be translate. These are the two steps in this question. So firstly we'll translate and check for number of overlapping ones, and we'll store it in the max value. So after that, in left up dash we'll move to left. So we'll check for the number of overlapping ones, which will be 1 in this case. After this we'll move to left and check number of overlapping ones, which will be 0. After this we'll move to up, translate up and check number of ones. So number of ones overlapping will be 1. Move to left, so number of ones overlap will be 3, and left, check, left and check, up, check, left, check, left, check, left, and it was gone out of image 1, and we'll move to translating up. So after translating up, we can see that it is gone out of image 1. There will be no overlapping, so we'll stop the process. So we have translated every possible way in left up direction. Now we'll go on to right up direction. So in right up direction, firstly we'll take only the first column. So we'll check it, and we can see that there is no overlapping ones. After that we'll move to left, and we can see there is only and there is no overlapping ones, and move to left, and there is no overlapping ones. So finally we'll move up and we'll check. So there is no overlapping ones. We check this, so there is no overlapping ones, and we'll check original. So we'll ignore the first row and check. So after this we'll check with this and move to right and move to right. So we'll try every translation, possible translations. So after this we have completely checked out the right up direction. So now we'll go and check with the right up direction. So for right up direction, we can take the given image and place it in the original image, that is image 1, and after that we'll move to right and check, translate to right and check, translate to right and check. After this we'll move to translate to up, check, translate to right, check, translate to right, check, translate to right, check. After this we'll move to translate to up, check, translate to right, check, translate to right, check, translate to right and check, and move to translate to up. So after this we have clearly seen that the two images won't overlap after this condition. So we have checked every possible direction, right up direction. Now we'll move on to left down direction. So how to translate to left down direction? So in left down direction, we take the given image and place it over the image 1, and we'll move to left, check, left and check, left and check. We'll move to down, we'll check, translate to left, check, translate to left, check, translate to left and check. So we'll move down, translate to left, check, check and translate to left. After this we'll move, that is we'll translate to down, and you can clearly see that we have tried every translation in left down direction. So we can mark this as done, and we'll move to right down direction. So for right down direction, we will take the given binary matrix and place it on the image 1, and we'll go to right, check, translate to right, check, translate down, right, 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 down, right, right, right. On the every translation we'll check the number of overlapping ones, and finally we'll get the number of ones. So for translation, for the first step, we can clearly see that there is only one step that is followed here. So we'll use a for loop to start with every index of image 2. For step 1, start with every cell. This is the step 1. In order to check, for a check step, that is count overlaps, let's call it as count overlap. We have 4 directions, right? That is left up, right up, left down and right down. For 4 directions, we'll have we can have 4 indices, with 2 indices will be having the indexes of start of the image 2 and 2 for image 1's start. Image 1 start will be, in this case of left up, we'll start the iteration from 0, 0. So these are the indexes, right? So 0, 1 and 2. For left up, we start with 0 and 0. For right up, we'll start with this. So it will be n 0, n minus 1. So it will be 0, n minus 1. And for left down, it will be from 0, row will be n minus 1. So it will be n minus 1, column will be 0. So for right down, we will start the image from, that is image 1 index from n minus 1 and n minus 1 and move in this direction for right direction, and in this case of right down up direction, we will move this direction. So her right up will start from here and move this way. For right down, we will move upward this way, and for left up, we will move in this direction. So it will be, so this direction. And for left down, sorry, wait a second. So for left up, we'll going in this direction, we'll be using this direction. So we'll start with this, that is this 0, 0 and move to this way. So it will be this direction for in case of left up, and in case of left down, we'll go up this direction. So it will be, the direction will be this. For left up, it will be this. And for right up, we'll start with 0, 1 and move in this direction. So which will be, this will be the direction for right up. And for right down, which will be starting from here, we'll move in this direction. So this is the direction. There are 4 directions. So the logic is completely based on how we move the 4 direction. So we are going to move based on the index. So this is what all about the approach. The time complexity of this approach is big of n power 4, since we start from each index, and for each start we are going to check, which is going to take n square, that's it. And space complexity, this is time complexity, and space complexity is going to be constant, which is big of 1. So this is the time and space, that's it. So if you are not clear about this approach, so you will be very clear in the coding section. So let's move on to coding section. Firstly, we have global variables for image 1 and image 2, and for we'll have a variable n as global variable. So we'll declare the global variable image 1 and global variable image 2, and global variable n as image 1 dot length. So after this, we'll start with every index. So I less than n I plus plus. For int j is 0, j less than n, j plus plus. So before that we'll have a max value which will be, let's call it as answer will be 0 first, which will be the number of overlapping ones, and we'll compare the max with count overlap. We have a helper function count overlap for each direction. For first direction will be left up and we'll pass the start indices, and for next we'll pass the current start with right up direction. So I comma j and comma count overlap of left down direction and comma count overlap of right down, and we'll pass the start index. So finally we'll return the answer. So we'll write the helper function which is for first direction, that is count overlap LU left up direction. So we'll get to two arguments and we'll have count as 0 initially, and we need to, this is the step 2 which is counting number of overlapping ones when starter image to in I comma j. This is the step 1, translating img2 to every possible ways. And after this we'll have R1 and R2, which will be R1 and R2 will be for denoting the row of each images, and R1 will be 0 starting from 0, and R2 will be I, and R2 will have condition like till n. So R2 plus plus R1 plus plus. So we'll move in this direction, right? So wait, so we'll, for left up we'll move in this direction. So we are incrementing row first, and C1 and C2 will be for denoting the column indices for image 1, that is img1 and img2. So C1 will be 0 and C2 will be j, and C2 less than n, C2 C1 plus plus C2 plus plus. So count plus equal to img 1 of R1 C1 and img2 of R2 C2. So what is this condition? It's nothing but this expression will return 1 only if both the value at image 1 and image 2 of respective cell are 1. If any either is 0 or both are 0, it will be returning 0. So it will not have any impact over count. So finally we'll return count variable. Yeah. So we have completed the first direction. Now we'll go with the second direction. So we'll just copy up and paste it. So for left, we are going to write the helper function for right up direction. So for right up, let's get into the paint. So for right up, we have, see clear said, image 2 will be starting from 0 1 column n minus 1. So row is R1 is 0 and C1 it should be n minus 1. And see the, let's see the direction. Direction will be from down left. So row will be incremented and column will be decremented. So row is incremented and column should be decremented, and we need to change the base case. So column should be decremented, right? Yeah, this will work fine. So next we are writing the helper function for third direction, which will be left down. So LD. So for left down, let's see. So for left down, we are starting from n minus 1 and 0. So R1 should be starting from n minus 1 and column should be 0, and the direction will be upward right. So upright will be column will be incremented and row will be decremented. So row should be decremented, R1 and R2 will be decremented and column will be incremented. So we'll check if bounding boundary case boundary condition will be checked. So C2 should be less than n. Yeah, this will work fine. So next we are taking the final direction. So we are writing function for final direction, which will be RD, that is right down direction. So for right down direction, let's see the PPT. So for right down direction, R1 will be that is image 1 will be starting from index n1 and n2. So yeah, row is n1 and column should be n1, n minus 1, and the direction will be up left. So it should be row will be decremented and column will be decremented. So both will be decremented. So you need to change the boundary case to it should be 0 greater than or equal to 0. So yeah, we have coded it up. Let's check it. Actually, we are getting wrong. So let's check with one condition. So if I is 0, I is 2, 1 and j is 1, let's print up. So it is displaying only 1. So what is the condition which I missed out? So in this case, I is 1 and j is 1, it should be written 3. So what have you missed out? It's working, it's fine. And so let's print and check here. So we'll check here. So if R1, so if I is 1 and j is 1, let's print and see. Whether we are iterating properly or not. So it will be 0, 1, 0. Let's mg1. So after this, we'll check R2 and C2. It's printing 1 comma 2, 1 comma 1, 1 comma 2. So we'll also print the R1 and R2. R1 and C1. It's 0 1 0 1 comma 1 0 1 1 1 comma 2. Now both will be 1, right? So 0 comma 0. So sorry, I have given wrong condition here. So it should be img r1 c1 r2 c2. So let's change it up. Let's check it. That's working. So let's check with other test cases. Yeah, it's working fine. So let's submit it up. Yeah, it's accepted. And as I have mentioned, the time complexity is big of n power 4 and the space complexity is big of 1. And there are pretty interesting solution in the solution column in the Leetcode. So I kindly ask you to check this up. So that's all about this video. Have a great time.